Hello, chemistry students. This is Mr. Reynolds, and this is day 6 of your online learning. This is Tuesday, March 24th. We're going to do a little, you did some with hydrocarbons yesterday, so we are going to do just a little review and some add-on, just other steps with that, okay? If you remember the hydrocarbons from yesterday, hydrogens and carbons only, is the backbone molecules of all the organic ones that you have to study, all the carbon-containing molecules that we have that make, and most of those make up living organisms. Okay, we had one carbon atom, if you remember the name of that, was methane. Two carbon atoms was ethane. Okay, so it was C2, and remember times 2 plus 2, H6. This was methane, gas in the lab that you use to light the burners and heat your home. Natural gas, C1 carbon times 2 is 2, plus 2 is 4, CH4. Okay, then we had propane. Butane was 4. Let's do the chemical formulas for those. Remember, the chemical formula tells you what is present and how many of each. So but is 4, ane is single bonds, hydrogens times 2 plus 2 is 10. Prop is 3, so C3H8. Okay, and then from 5 on, you should be able to get those. You knew these prefixes before. Let's race. 5 is pentane. 6 is hexane. Oh, and you have to race without making any mistakes on it. 7 is heptane. 8, octane. 9 is nonane. And 10 is 10 years, decane. Okay, I'm going to put the number of carbons because that's easy, and you do the number of hydrogens. C6H whatever. Remember, hexane blew up the sewers. Heptane is C7. H something. Octane C8. Nonane C9. Decane C10. H what on all those is what you need to come up with. So C5H what times 2 plus 2 is 12. C6 times 2 plus 2 is 14. C7 times 2 plus 4 is 16. C8 times 2 is 16, 17, 18. C9, 18, 20. And C10, 10 carbon atoms in a chain, is H22. Okay. Now, a big deal with these carbons, which I didn't say, I failed to say yes. I'm gonna make this blue. I want to change in color. We did carbon. Now let's look at ethane. 2 carbon atoms bonded, surrounded by hydrogens. So each carbon is bonded 4 times. All this should sound painfully familiar. Okay. Eth means 2. All right. Each hydrogen is bonded once. Each carbon is bonded 4 times. That's what it likes. Let's do the Bohr model. Looking at carbon bonded to carbon, okay, 6 protons, 6 neutrons, 2 electrons on the first shell, 4 on the second cell. Since we're going to show bonding, let's spread those out. Here's one of them, 2, 3, 4. That can be this carbon, okay. The next carbon, let's show these bonded because it's, like I said, it's a real strong bond. These covalent bonds are super, super, super strong, okay. And if one of them breaks, if we break a bond, tremendous amount of energy is released. All right. So the next carbon, I'm showing covalent bond. I'm showing the overlap here. Okay, this was electron from this carbon atom. Here's the electron from this carbon atom. Okay, inner shell has 2. Kind of doing it backwards. 6 protons, so it's got to be carbon. 6 neutrons is a mass of 12. And just pretend that these two are the exact same size. Here's my carbon atom. Here is the bond between them. Remember, that's shared electrons. 1 electron from this atom, 1 electron from this atom. Okay, so each line that we see here, each covalent bond, it's 2 electrons. Okay, sharing. All right, I did not put the electrons for this one, so here was 1. Second one, that's too close. Electrons don't like each other. We got to spread them out. Okay. All right. So 1 electron, 2, 3, 4. Okay, and this was the first electron right here, I believe. Okay. All right. Anyway, this is considered a fairly short bond because it's just to the second shells of each atom. Right. So the distance from this nucleus to this nucleus is only a certain amount, and half a distance of a circle is a radius. So the radius, the atomic radius from one atom to another, from one atom to its outer shell where the electrons are being shared. Okay, that's why the periodic table works for this real well. It's set up for valence electrons. It's showing which ones are valence electrons. So you can picture if you just need to get the stable octet. Each carbon has 4. Hey, it's going to need 4 more. Well, look at this. Here's 1 bond. Here's 2. Here's 3. Here's 4. Voila! It does that. Okay. Next step, we're going to go to the next slide. A lot of stuff on here. So next slide is, let's take that same ethane molecule that we had, okay? 2 carbon atoms surrounded by hydrogens, all right? So each carbon, like I said, has 4 bonds. Each hydrogen has 1, and they're content. They fill their outer shell with electrons. Super strong bond, this covalent bond here, sharing 2 electrons, 1 from this carbon, 1 from this carbon. All right. Now here's the next step in naming these. We said the name of this is ethane. All right. So what we're doing now is this is like if you're a basketball, if you're in a game, basketball, volleyball, baseball, and you're stinking up the place, and the coach says, "Joe, get out of there, get out of there," and he puts a substitute in, gets someone off the bench and sticks them in there, right? And anything that wants to bond, just has a single bond, can be substituted in for a hydrogen, okay? And this is called a substituted hydrocarbon. Substituted hydrocarbon. Okay. In this, if we substitute an OH group in, okay, if we substitute an OH group, we just made this thing an alcohol, okay? All right, and actually this one is, and notice the OL in the alcohol name, okay? If this substance is now, the formal name is ethanol, okay? This is the intoxicating substance in beers and wines. It's one of the few alcohols that that can be consumed and you don't die right off. You don't die pretty quick. Okay. Like I said, the F means 2 carbon atoms. ANE means single bonds. There it is between the carbon atoms. OL means I've got an OH group on there. I substitute an OH group in for one of the hydrogens. Okay. I'm going to go to the next slide here. We're going to go back one to CH4. Okay, what was the name of it? Good, methane. It's almost like you all were here. Methane. It's carbon atom in the center, surrounded by 4 hydrogens. Each hydrogen is bonded once. It picks up 1 more electron, so it's got 2 in its first shell. It's content. Carbon picks up 4 more. Had 4, stable octet. It's good to go now. All right, we can do the same thing here. Let's substitute. Let's get a hydrogen out of there and stick an OH group in there. And voila, we just made that an alcohol now. OL, the formal name of this now is methanol. Methanol. Old name is methyl alcohol. Okay. All right. There's this methanol also still appears to be, it's a clear liquid, just like ethanol was. Ethanol is. Okay. It's an OH group. Let's be lazy with the hydrogens and just show the bonds. If it's anything other than a hydrogen, I have to put it. Okay, like this OH group. Okay, I have to list it if it's anything bonded to those carbons besides hydrogens. Okay, so ethanol and methanol Again, that's ethanol and methanol. Both are clear liquids. They both have that alcohol scent. As the vapor's coming up, we can smell that. And some people will, there's another name for them because of how they're produced. This is also known, methyl alcohol is also known as wood alcohol. Okay. Ethanol, or ethyl alcohol, is also known as grain alcohol. Okay. This one, methanol. Some people will consume methanol thinking it's ethanol, and they want to get drunk, and they consume methanol. And first of all, they go blind, and they're feeling sick and stomach upset, and they ate something bad. And I want to say they might be blind for about half a day, and then I think it's usually into the next day they die. So like I said, most alcohols will kill you. Okay, ethanol is one of the ones that doesn't kill you right away. If someone drinks that too much, yep, they're going to die from that also. The reason that I'm mentioning these is because in industry uses these a lot. It's very, very inexpensive, easy to make, cheap organic solvent. A lot of organic substances will dissolve in it. So organic solvent. They have to the industry has to put some substance in there to make it unfit for human consumption. Okay, and whatever they add, we then say it's denatured alcohol. It's not fit to be consumed. Okay, and for people who don't want to read the fine print, there's usually the skull and crossbones on there, and I don't think I can sketch that. But they'll put that design on there, the skull and crossbones, so that you do not consume that. Okay, because like I said, well, these have very similar characteristics, and just looking at those, same appearance, same smell, and that would be a bad mistake on it. And if something with the skull and crossbones on it, that's going to kill you also. But it's kind of surprising that industry has to put a substance in there so that you can't drink this without getting sick. I'd like to show you in the lab how to heat these up. We can't use a flame because these are very, very flammable. We'll have to heat up a liquid and then put these in a container and then set them in there. It's a very standard way to do it in lab because, like I said, there's a lot of things. This ethanol and methanol are both, ethanol and the methanol are both very, very commonly used organic solvents. You just have to use them carefully when you're doing that. Okay. Thank you very much. Bye.